And with the price elasticity of demand, what we're calculating is between 2 points on a demand curve, we're calculating what would be the percent change in quantity versus the percent change in price. Okay, so we would calculate between these 2 points, percent change in quantity over percent change in price. And so the formula, this is in your notes, so you don't have to write this down. The formula, well, there's actually two formulas that we went by. So this is in your notes. You don't have to write this down. So these were the two formulas that we were using. The result was exactly the same. This one here is just the slightly simplified version. Good. Okay, and so what we ended with, last class we had done measurements of elasticity on the upper part of the demand curve, in the middle and the lower part. And so what we found is the upper part was elastic, meaning that the elasticity was greater than 1. Unit elasticity was exactly equal to 1. And inelastic elasticity is less than 1. And so then that ties into our formula here. When the elasticity is less than 1, it means that the numerator is smaller than the denominator. So the quantity change would be relatively small compared to the price change, which is what inelastic is, right? It would be for like a necessity, so you're not going to change the quantity very much when the price changes. Whereas elastic goods are the opposite. If it's greater than 1, then the quantity change is bigger than the percent change in the price. And so that is when people change the quantity quite a bit when the price changes. Or we say that they're price sensitive. So they're sensitive, they make drastic changes when the price changes. Whereas here, inelastic, they're not very price sensitive. Good. Okay. Any questions? So far, that's everything that you learned last class. Okay. All right. So now we're going to tie that into how the price elasticity of demand will affect revenue for a business. And so I talked about this a bit last class, that for a business, understanding the elasticity of your consumers is really important because you need to know how to set your prices. And if you change your prices, it will change the quantity that people buy, but how much, right? You have to be very careful. All right, so total revenue is the same as the total expenditure for your consumers, which is just price times quantity. And those go in opposite directions, right? If you increase your price, you will sell less. If you decrease your price, you will sell more. And so then what happens to your total revenue depends on which variable changes more, which ties into elasticity here, which will change more. And then that in turn will determine whether you make more money or less money when you raise your prices or lower your prices. All right. So looking at this table, we've got price and quantity. So this is like a demand schedule going that way. So let's calculate the total revenue. Okay, so 0 times 10, 1 times 9, 2 times 8. Okay, now stop there for a minute. So what's happening is that this is you increasing your price. Then as you increase your price, you are selling less of the good. But the increase in the price is more than making up for the decrease in the quantity, and therefore you make more money, right? So the increase in the price more than makes up for the decrease in the quantity that you're selling, and you make more money. So this then, the increase in the price or the percent change in the price more than makes up for the decrease in the quantity. So that means the percent change in P is greater than the percent change in Q. And so that makes a fraction of less than 1, which is inelastic, and so that's for the lower part of the demand curve where you've got higher quantities and lower prices. All right, now we get to 5 times 5. And now we go back to 24. So now the total revenue starts to go down. So after the price of 5, what happens is the increase in the price no longer makes up for the decrease in the quantity. So even though you're increasing your price and you're getting $1 extra per unit, the fact that you're selling one less unit now is more significant, and it starts to bring your revenue down. Okay, and then likewise, as we continue down the table, your revenue will keep going down. And so the increase in the price no longer makes up for the decrease in the quantity. Now that change in the quantity is having a bigger effect on your revenue. So the change in the quantity is bigger than the percent change in the price. And so that's greater than 1 elasticity. That would be the upper portion of the demand curve then, where you've got higher prices and smaller quantities. All right. So what's happening, I'll make some extra notes up top here. Okay, so total revenue equals P times Q. Now over here, in this part of the table, from 0 to 5, you are increasing your price and decreasing the quantity, but the increase in the price more than makes up for the decrease in the quantity. So it's like a big increase here and a little decrease here. And so if you've got a big increase for P and a little decrease for Q, I'm getting mixed up. The net effect on your revenue is that it would go up, which we can see there. Okay, so revenue would go up. But on the other side of the table here, so total revenue is P times Q, and again, the price is going up, but now the quantity is going down, and it's a bigger percent change. So then the net effect is that your total revenue goes down, which we can see there. So if you're selling the good and you're thinking about increasing your price, it would only make sense to increase your price if you're starting with a low price to begin with. But if you've already got high prices and you increase your price again, you're just going to lose money. Good. Okay. So I'll switch over here. I've got some notes now to go under the table. There we go. Okay. All right. So in the beginning of the table, it's the price. The effect of the price outweighs the effect of the decreasing quantity. So you raise your price, decrease the quantity, but the price change is more significant. And then on the other side of the table, it's the opposite. Yeah.
For that graph, doesn't it have a consistent slope throughout?
Yes. Yeah. Yeah. So let's see what's coming up next.
So then why does elasticity?
Just because the elasticity is a different formula than the slope. So slope would be just a change. And it would go the other way too. So the slope would be rise over run, so it would be change in P over change in Q. but then elasticity is a percent change. So you're going to get a different result, yeah. So that's what we were looking at last week here when we did the elasticity calculations at different points along this demand curve, right? You get different results depending on where you are, if you're already at high prices or low prices. So yeah, so the elasticity will be different along the demand curve, even though it's a straight line. Okay, all right. All right, okay, so now we have two terms called the price effect and the quantity effect, which is what that is sort of talking about. Now, total revenue is P times Q, and this, these will go in different directions. So if this goes up, this will go down, and then they both affect your total revenue. If you raise your price, you're getting extra revenue per unit, but then you're selling fewer units. And so your revenue will go up per unit, but then the number of units goes down, so your revenue goes down because of that. Or the other way, if you lower your price, you will sell more, and so both of those will change your revenue. You're going to get less revenue per unit, but then you're going to sell more units. So the price effect is just the change in the revenue per unit that you're selling, whereas the quantity effect is the change in your revenue because you're changing the number of units that you will sell. Okay, so price effect and quantity effect. Okay, so on the next page we'll do an example where we can illustrate these two effects on the diagram. Okay, so the price decreases from $7 to $6 per unit. Okay, so at $7 per unit, the revenue is 7 times 3. So the taller rectangle here, that would be the total revenue. But then at $6, you get paid less, $1 less per unit, but you sell an extra unit. So 6 times 4 would be your revenue at $6. So your revenue goes down per unit, but it increases by selling an extra unit. So the decrease from lowering the price, this rectangle here would be the price effect. And then, so your revenue goes down by that much, but then it increases to the right. And so this would be the quantity effect. And then we could figure out what those areas are. So the price effect, I'll just put PE for short. This rectangle is $1 times 3. So you're losing $1 per unit on the 3 units that you were selling, so you're going to lose $3 when you lower your price, but then you sell an extra unit, and so that's the quantity effect, QE, and the extra unit that you sell, you're getting paid $6 for it. So your total revenue goes down by 3, but up by 6. So your net effect on total revenue is that it goes up by 3. That's right, which we can see here, $21 up to $24. So it goes up by 3. I'll put over here, so minus 3 plus 6. There. Okay. So now what we're going to do for this exercise is look for those price effect and quantity effect on page 4. So this was the exercise that we did last week. Okay, so we're doing exercise 2 based on this graph here that we did last week on Friday. Okay, so first between A and B. Okay, so at A, the revenue was 9 times 2, and then at point B, the revenue would be 8 times 3. Okay, so the upper rectangle is the price effect. You're losing $1 per unit on the 2 units that you used to sell, but now you're selling an extra unit, and you're selling the 3rd unit at a price of $8. Okay, so I'm going to fill in this part as we go along. So from A to B, the price effect is that you are losing $2. So that would be this here, so $1 times 2. But then here, revenue increases out to the right because you sell a 3rd unit, and the price set for the 3rd unit is $8. So the quantity effect is plus 8. Okay, now at C, your revenue is $6 times 5 units. And then at D, it's $5 times, okay, sorry. I have a cold. My brain is, and obviously my mouth too, are not working 100%. Getting things mixed up. Okay, so revenue did not change, right? 6 times 5, 5 times 6. So the revenue in both cases would be $30. So what's happening is that they will lose $5 here because they're losing $1 per unit for 5 units, but then they sell an extra unit for $5. So they lose 5 and gain 5. So price effect is minus 5, quantity effect is plus 5. All right, and then the last one, at E, revenue would be $3 times 8. And then at F, it would be $2 times 9. So they're going to lose $1 per unit on 8 units. They're going to lose $8. And then they sell an extra unit, but the extra unit that they sell, they're only getting paid $2 for it. So they lose 8, gain 2. Okay, so last one there, minus 8 plus 2. Yeah, so the revenue goes up. The revenue went up here by 6. No change there. Revenue goes down by 6 between those 2 points. Good. Okay. Any questions? Yeah.
Can you go over C and D again?
Oh, sure. Yeah. So so when the price goes down from 6 to 5, they will lose $1 per unit on the 5 units that they were selling. So they lose $5, but then they sell an extra unit for a price of $5. So they lose $5, but then they gain $5. Yeah. Okay. Any other questions? All right. Okay, so the next page summarizes what you guys have learned so far about elasticity, starting with inelastic. Oh, there we go. Yep. There. Okay. So starting with inelastic. All right, so for inelastic, the elasticity is measured as less than 1. And so then this fraction is less than 1, which means that the numerator has to be smaller than the denominator. So that means that the quantity effect is smaller than the price effect. So the price effect is stronger. So if you increase your price, you will sell less, but just a little bit less. And so therefore the net effect is that your revenue would increase. You would make more money. And if you decrease your price, you will sell more, but only a little bit more. And so the net effect is that your revenue would decrease. Okay, so this would be for a necessity, kind of good. So say medicines, right? So you may hear sometimes in the news about pharmaceutical companies raising the price of medicines that they're selling. Why do they do that? They're going to make more money, way more money, especially, you know, the more necessary it is, the smaller the quantity change. So when they raise their price, they only maybe sell a little bit less, they make more money. And it's also why you never see things like, I think last class I talked about milk. Do you ever see milk on sale? No, not really, because they would just lose money. If they put something like milk on sale and it's a necessity for people, they'll buy a little bit less, but you can't store it for very long, so you don't buy too much more. And anyway, and so then they just end up losing money. Okay, elastic, everything's the opposite. So elasticity is greater than 1, so that the fraction is greater than 1. That means that the numerator now has to be bigger, which is the quantity change. So the quantity change is bigger. All right, so this will be a good that is a luxury, or a good where the consumers have lots of other choices, like substitutes that are similar. And so the consumers then are going to be more focused on the price. And when they have a lot of substitutes, consumers try to buy whatever one is cheaper. So they're very sensitive to the price. So if you raise your price, people will buy a lot less. And so then you will lose revenue. If you lower your price, people will buy a lot more, so you will increase your revenue. And so that's why you tend to see sales on things that are luxury items. Okay, so raising the price will decrease your revenue because you sell a lot less. And decreasing the price will increase your revenue because you will sell a lot more. Yeah, your revenue would not change because with unit elasticity, if you raise your price, you will sell less, but the two effects will be the same. And so then no effect on revenue, or the opposite. If you lower your price, you will sell more, but those two will net out to no change there. Yeah. So that means that the quantity change and the price change, the percent changes are the same. And so then you get an elasticity that's exactly equal to 1. And so then as a business, if you change your price a little bit, either way, it's just not going to make a difference for your revenue.
So is it always true that when price decreases that total revenue will increase?
So only for elastic, So if price decreases, your revenue will only increase if you're selling so many more units that it makes up for the price decrease. And so that's only if it's elastic demand, yeah. Because otherwise, if it's inelastic, you'll lose revenue in that case, yeah. Yeah, so it just depends how the consumers respond. Okay. Now, so the slope is not the same calculation as elasticity, but the slope will give you some indication about how elastic or inelastic the demand will be when you do the elasticity calculation. Because, for example, if a demand curve is very steep like that, then between 2 points on the demand curve, you're going to have a very large price change and a small quantity change. So for sure, if you did that calculation, you would get an elasticity that's less than 1. It would be inelastic. So it's not the same calculation, but you would get a result, a predictable result. And if it's a very flat demand curve like this, it would be the opposite. If you calculated the elasticity between these 2 points, you would have a small price change and a large percent quantity change. And so that would be elastic. Okay, so the slope is not the same calculation, but it does tell you about what kind of elasticity you'll find. So generally, a steeper demand curves are more inelastic. And we'll look at an extreme case here of when it's perfectly vertical, then it is called perfectly inelastic. Okay, so a vertical demand curve would be perfectly inelastic because the quantity would not change at all. So this would be something that consumers felt was really, really necessary. So I put insulin as an example. And then insulin is a good example because if the price changes and you have diabetes and you need a certain amount of insulin, you're not going to change that, right? If the price goes up, you're just going to find the money to pay for it. If the price goes down, you're not going to start taking more insulin because that will also not be very good. So you have to take just the right amount of insulin, and it doesn't matter if the price goes up or down, you're going to buy the same amount of insulin. Okay. Now the opposite, so flatter demand curves like this will be more elastic. And if it's perfectly flat, if it's a horizontal line, it's called perfectly elastic. Now with a perfectly elastic demand curve, it means that consumers are super sensitive to price changes. If the price goes up even a tiny bit, they will say, not going to buy it anymore. No. If at a low price, they will buy as much as they want, whatever that is. But if the price goes up even a little bit, they will say, no, don't want to buy it anymore, forget it. And so this will be something that is, well, definitely not a necessity, something that's very much a luxury, or it's some kind of situation where consumers have so many other substitutes to choose from that they can easily switch from one substitute to a next, and they'll just stop buying the one that has the higher price. All right, so perfectly elastic, and it means that the quantity demanded decreases to 0 with any increase in the price. Okay, so if it's a horizontal line, that means that mathematically you'd get an elasticity of infinity. Obviously, people wouldn't actually buy an infinite amount of something, but what it means is that at the low price, people will buy as much as they want, and then if the price goes up even a little bit, they will stop buying the good. Okay, so yeah, so this is when consumers have a lot of other options. And the kind of substitutes we would say are perfect substitutes. So something where the competitors have a good that is exactly the same. So with gas, we talked about Esso gas as an example last week, right? Gas stations all sell the same gas, and it's very rare that anybody has a preference. Now, some of you might. My husband somehow thinks that one gas station is better than the other. And I think it's all in his head. So all gas is the same. You don't care then where you get it from. If you've got two gas stations that are right next to each other and one is even 1 cent cheaper per liter, you're going to go there, you're going to fill up your car, and you're going to get 0 at the other one where it's more expensive, right? Okay, so perfect substitutes. All right, okay, so this leads into the next discussion is what affects elasticity. And so the first is availability of substitutes. So elasticity will be higher when more substitutes are available. Right? So demand will be more elastic when there's more substitutes available. Which is why competition is awesome for consumers. When there's competition, what it means is that there's other producers selling similar products. And the more choice you have as a consumer, the more price sensitive you are. And that's why when there's more competition, all the sellers have to try and lower their prices and lower their prices, right? So more competition makes our demand more elastic. We're more sensitive to the price when we have lots of other options. Okay, so the next thing is how necessary the good is. So if it's necessary, it's inelastic demand. So elasticity is lower if the good is considered a necessity. Okay, and then let's look at the examples here. So these are estimates of price elasticity of demand for these different goods. Now, eggs, that's something that is unique, right? So you can't really find many substitutes for eggs. I mean, there's like quail eggs or duck eggs, but usually we just want chicken eggs. Whereas a car, if you're looking for a car or a truck, you've got lots and lots of choice. And so because you've got so much choice, then your elasticity of demand for Chevrolet vehicles would be very high. And then foreign travel, so this would be like going on vacation traveling, obviously a luxury. Restaurant meals, a luxury. Coffee, though, now, everybody will have slightly different price elasticities of demand. So for coffee, if you're someone who wakes up and you have to have your cup of coffee in the morning, then your elasticity will be a very low number, very inelastic demand for that. All right. Last one is time. So when we measure elasticity, we're measuring the percent change in the quantity after the price changes. But the percent change in the quantity that you measure will depend on how much time you give the consumers to make changes. So with gas, for example, if the gas prices go up today, then by tomorrow, if you have a car, there's not much you can do. But if we observe what you have done after a year or after a couple years, then you will have made more changes. You might have bought a different car that's more fuel efficient, or an electric car. You might have started taking the bus. You might have gotten in shape and started riding your bicycle, whatever it is, right? If you give a consumer more time, then you're going to see a bigger change in the quantity because they'll have been able to figure out how to make adjustments, right? So they can find alternatives. Okay, so over time, people find more substitutes. And also more substitutes are developed. So this statistic for gas price elasticity of demand in the long run, this is an old statistic. In the past 5 years or so, there's been such a huge increase in the amount of, or the availability of more affordable electric cars, for example. So I bet if you studied our estimated elasticity today, then that would be a higher number than it is there. Okay. All right. Any questions? All right. Okay. So now so far what we've been talking about in Chapter 6 is price elasticity of demand, which is when you're measuring the elasticity between 2 points. And so you're measuring the quantity change relative to the price change. Okay. But we can also measure people's response when other factors change that shift the curve. Now in Chapter 3, I think there were 5 things that would shift the curve, but we're only talking about 2 in this chapter. So one is income. If your income changes, then that will shift your demand either direction, depending on if your income goes up or down, and depending on if the good is a normal good or an inferior good. And then the other one we'll talk about now is the price of related goods. So there can be substitutes, or there can be, what's the other one? Substitute goods or complement goods. Yes, right. And so when those prices change, it will also shift your demand. And so then what we'd be talking about is, okay, even if the price has stayed the same here, then the quantity that you're buying of this good will either increase or decrease. So we're also then measuring a percent change in the quantity, but it's now going to be in response to something else, either an income change or a price change for the related good. All right, so first one is related goods. So this one is called cross-price elasticity of demand. I know, they're long titles. Cross-price elasticity of demand. Okay, so the beginning of the chapter was just called price elasticity of demand. So this one is cross price. So we're talking about quantity change for one good when the price of the related good changes. Now the formula is the same, except we're talking about a quantity for a good A, and then how that changes in response to the price change for the other good, good B. And we do not have the absolute value signs like we did for price elasticity of demand. Now the reason why we used the absolute value signs for price elasticity of demand is that you would always get a negative result, and so the negative sign just didn't mean anything. But here, you could get a negative or a positive result depending on if the demand shifts to the right, so the quantity increases, or to the left, so the quantity decreases. And whether it shifts to the right or left will depend on whether the goods are complements or substitutes. Okay, so for complements, like say staples and staplers, if the price of staplers goes up, what will happen to demand for staples? It'll go down, right? So then you have a negative result. You have an increase in the price for the good B and a decrease in the quantity that people are buying of the good A. So that will be complement. So you have a negative result for complements. So the cross price elasticity, so it would be negative, so less than 0. And then for substitutes, it would be the opposite. If the price of Esso gas goes up, demand for Chevron gas will go up because people will go to that gas station instead. So you get a positive result. Price increase for Esso gas, people buy more Chevron gas. And then the size of the number that you get. So the number could be positive or negative, and then the size of the number will tell us how closely related the goods are. So say staples and staplers are very closely related because there is absolutely no use for one without the other, right? They have to go together, and you just wouldn't buy one without the other one. Whereas something like, say, popcorn and movies, they don't have to go together. They go together, but you don't have to go together. You can consume one or the other separately. So for popcorn and movies, those are complements, so you'd get a negative result, but it would be a fairly small number. And then staples and staplers, you'd get a negative result, but it would be like a negative big number. Okay, so if the elasticity is small, that means that the relationship between the two goods is weak. So if you get a small number, it's just a weak relationship between the goods. And a larger number, positive or negative, means a stronger relationship between the two goods. And so here we have a couple examples of substitutes. So say the closer they are, the closer the substitutes are, the more consumers will respond to the price change. So say for Esso gas and Chevron gas, they're substitutes, you get a positive result, and it would be a big number because people really respond strongly to even a small difference in the price. Butter and margarine. Now, there, probably most people have a preference, but it's probably a fairly weak preference, right? Like if you really like butter, you're not going to make a huge fuss about having to have margarine, or the other way around, right? So they're pretty close. they look the same pretty much too. Whereas beef and pork, those are also substitutes. You would have one or the other, but there's, you can tell the difference. They taste different. People will have a stronger preference between the two. So they're not as substitutable as butter and margarine. Okay, last one is income. Okay, so this will be called income elasticity of demand. And so this will not measure any price change. This is going to measure your response to your income changing. So the formula is similar. We'll be looking at how much you change the quantity that you're buying, but relative to a % change in your income. So % change in the quantity that you buy relative to a % change in your income. And again, we don't have absolute value signs because we do want to know what direction the change goes. Because when your income goes up or down, your demand can shift right or left depending on whether it's normal good or inferior good. So what happens, like if you get a negative result or positive result, that will tell us if you think that the good is normal good or if you think it's an inferior good. So if your income goes up, and you buy less of the good, what kind of good is it? Inferior good. So a negative result then, so if your income goes up and then you decrease your quantity, negative result, that tells us that you think it's an inferior good. Whereas if your income goes up and you buy more of it, then that's a positive result, and that tells us that you feel it's a normal good. And then, last thing is that for normal goods, we can further classify the normal good as a necessity or a luxury. And we'll do that the same as we did with price elasticity of demand. If it's more than one, it's a luxury. If it's less than one, it is a necessity. Okay, so both of these are positive. It's just that this is positive and greater than 1, positive and less than 1. So luxury or a necessity. Okay, so here are some examples. So food eaten at home, obviously a necessity. Restaurant meals, not a necessity. That would be a luxury. Cigarettes, it's kind of like a necessity like coffee would be, right? Like biologically it's not necessary, but once you're used to it, you're kind of dependent on it. Public transportation, inferior good for most people. Okay. All right, so we're going to do exercise 3 now, where we have different situations. The first one, the price of good B increases from $10 to $12. Mary changes her quantity demanded for good A from 8 to 9. Calculate, so now we're calculating cross price elasticity of demand. And we're going to calculate it, and then we're going to figure out what type of good. So they would be substitutes or complements. But, you can figure that out before you even do the calculation, because when the price goes up for this good, Mary buys more of this good. What would they be? Substitutes, yeah, because she's buying more of the one that is relatively now cheaper, because this one is now more expensive. Yeah, so we can already answer this question. They would be substitutes. So to do the calculation, we do have to be careful with our signs, positive, negative signs. When we did price elasticity of demand, you're just leaving them all off anyway, so it didn't really matter. But now it will matter. Okay, so this will be P2, P1, Q2, Q1. Okay, so elasticity. All right, so Q2 is 9. 9 minus 8 over 9 plus 8. P2 is 12, so 12 minus 10. 12 plus 10. Okay, so this is a positive result. And now, I think I mentioned this last class, when we're doing elasticity calculations, the numbers are small. So you want to keep a few extra numbers after the decimal, probably. Anyway, so that should be... So I'll leave 3 numbers, say 6, 4, 7. Okay. Next one, the price of good B decreases from 20 to 18, and her quantity demanded for good A increases from 22 to 25. Okay, so now it's the opposite. The price decrease leads her to buy more of the other good. That must mean that they are complements then, because if one becomes cheaper and you get them both together, you're going to buy more of both of them. Okay, so for sure they're going to be complements. So we should get a negative result here then. All right, so Q2 is 25, Q1 22, oops. P2 is 18 minus P1 is 20. So that's where we're going to get our negative sign. Okay. Okay, next one is going to be income elasticity of demand. So Josie's income decreases from 80 to 60,000, and she changes her quantity demanded for good A from 45 to 50. Now again, we can just by that figure out if it's a normal good or an inferior good. What would that one be? Inferior, that's right, because she's getting poorer and she's buying more of it. So this would be inferior. So we should get a negative result then. Okay, so elasticity. Okay, so on the top, quantity change, so Q2 is 50. And then on the bottom, the income change, and the income, the I2 is 60 and the I1 is 80. All right, last one. Now her income increases and she buys more of the good. So that will be a normal good. And it will also be either a necessity or a luxury, but that will depend on whether the result is more than one or less than one. So we'll have to do the calculation to figure that out. Okay. All right, 3.4, more than one, so luxury. So we can add that here. So it's a normal good and it's a luxury good.